Hello everyone, welcome to Pre-Algebra with Miss Betsy. We are beginning a new chapter today. We're in chapter 7 and we're talking about multiplying and dividing rational numbers or multiplying and dividing fractions. Now if you're using the same text that I'm using, I am following right along with the Pre-Algebra for Christian Schools, first edition. It's published by Bob Jones University Press. If you're with us, we're in section 7.1 on page 217, and our topic today is simply entitled Multiplying Rational Numbers. You can follow along with any text in the world, or even if you're just interested in knowing how to multiply together fractions. Before we begin though, I have another lame dinosaur joke for you today, and this one says, it's a riddle I guess, what do you get if you cross a dinosaur with a dog? Well, you would get one very, very nervous mailman. So, I have a sketch that I've drawn on the board for you here, and obviously I've drawn it freehand, and obviously I am not an artist. But what I've drawn here, these are supposed to be three rectangles that are exactly the same dimensions. I've cut this first rectangle in half vertically and shaded one part of it. Our second rectangle, I took that same half and cut that in thirds and shaded one piece of it. For our final rectangle, final drawing that I have here, I divided the rectangle up into sixths to begin with, into 6 equal parts, and I shaded one part of that. And what I wanted you to see, what our book wants you to see, is that we take an object in half, we have half of it shaded. If we have, let me go ahead and change this around a little bit so that it illustrates what I want to show you. Here we have one half of this shaded, right? Now, what we're going to shade with two colors is 1/3 of that one half. 1/3 of one half is this two-colored shading here. Then with this second picture that we have over here, we just divided that into 6 equal rectangles to begin with and just shaded 1/6 of those. And what you see is that 1/3 of one half of this rectangle is exactly the same as 1/6. And what they want you to notice, what they want you to understand here is that if you have 1/2 times 1/3, if you were to multiply the numerators together and multiply the denominators together, you would end up with 1/6. So if you are taking a fractional part of another fraction, you're just multiplying together two fractions. 1/2 times 1/3, multiply the numerators, 1 times 1 is 1. Multiply the denominators, 2 times 3 is 6. So let's go ahead and look at this again. Reversing this, if we wanted to take 1/3 of 1/2, we already saw here that we had shaded 1/2 of this. We took 1/3 of that piece, and it was exactly the same as 1/6 of the rectangle. So 1/3 of 1/2 is 1/6. We've been doing some work earlier where in our studies where we were translating English words into algebraic or into arithmetic operations. Of means multiplication. 1/3. I'm going to go ahead and put that x in there because your book does, even though I don't want you using the x. 1/3 times 1/2. And what did you learn that is means, well, is always represents is equal to 1/6. So what you're seeing here is that to multiply fractions together, when you're multiplying fractions, you simply multiply together the numerators, you multiply together the denominators. You don't have to draw these little sketches. Can you imagine if you had 7/12 times 9/32? Can you try, you wouldn't be able to do a pictorial representation of that very readily at all. We just draw these little rectangles here to give you an illustration and to show to you that when you take 1/3 of a half, that's really the same as 1/6. And that illustrates to you that all you're doing is multiplying fractions. Of means multiplication. Is can of course be substituted. You can use an equal sign to substitute that. You multiply the numerators together and you multiply the denominators together. Now for many of you this will be a review of what you do when you multiply fractions. For some of you, however, it will be new. So hopefully this picture here gave you a little bit of an understanding of what's going on. And now you can simply take that understanding that you have from looking at the picture and use this little rule here. This is called multiplying rational numbers. It's in the middle of page 217. Your book is the white part, the teacher's manual is on the blue part. It says to multiply two rational numbers, multiply the numerators and multiply the denominators. Express the answer in lowest terms. For all rational numbers, a over b and c over d, b is not equal to 0, d is not equal to 0, a over b times c over d is equal to a times c, b times d. Okay, that really was very beneficial to you for me to read that, wasn't it? No, not at all. So let's look and see what they're saying. This is saying for all rational numbers a over b and b over d. What they're talking about here, they're saying, okay, you've got two fractions. What do we know about fractions, about rational expressions? These are integers. The denominators can't be equal to 0, can they? So that's why the rule here says that b is not equal to 0 and d is not equal to 0. B and d, because we have two separate rational numbers we're using, you have two different ways of representing those denominators, and because you cannot divide by 0, you have to put that little rule in there. Then they say, okay, a over b times b over d. They're saying if you have these two fractions, two rational numbers, that you want to multiply together, your rule for doing that is to write one long fraction bar, a times b, a times b and b times d. Can you see I'm used to going a and b and c? A over b and c over d. A times c is equal to b times d. What they've done is they've taken the statement that I just illustrated to you and said, okay guys, if you want to multiply two fractions together, 2/3 times 4/7, or 2/3 of 4/7, you multiply the numerators together, you multiply the denominators together. And that's how you arrive at the product of two rational numbers. You multiply two fractions together, you multiply the numerators, multiply the denominators, and express that answer in lowest terms. That's all this is saying. Except instead of using an illustration or example, where you have just two very specific fractions, it says, okay, this is what this looks like just using variables. This is the rule that works always, no matter what the fraction is. This is always true. If you're multiplying fractions, multiply the numerators together to get the new numerator, multiply the denominators together to get the new denominator. So, let's go ahead and do example 1 from our text. It says multiply 4/5 by 5/10. Four-fifths times 7/10. Excuse me. Now some of you might notice, look at this and see we have common factors. We're ignoring the fact that we have a common factor for the moment. We're saying we simply have two rational numbers that we want to multiply together. So how are we going to do that? We're going to multiply the numerators and we're going to multiply the denominators together. What does that equal? That equals 28 over 50. Is this fraction reduced to lowest terms? No, it's not, because both of these numbers are divisible by 2, aren't they? So you can divide both the numerator and the denominator by 2. 28 divided by 2, 50 divided by 2, and you have 14/25. That fraction is now reduced to lowest terms. And that's your solution to your problem, 4/5 times 7/10. You multiply the numerators together, multiply the denominators together, saw that your answer of 28 over 50 was not a fraction reduced to lowest terms. How did you know that? Well, 28 is even and 50 is even, so they both can be divided by 2. You performed that operation, and you're now at 14 divided by 25, and there's no common factor between them. So 14 over 25 is your solution. That's all that's involved in multiplying fractions. So let's go ahead and look at another example. And this one is from page 218. The example here is 3/4 times 5/9. And they're still using that x to indicate multiplication. Please lose that. Use a raised dot. Use a raised dot for multiplication. Just makes it easier not to confuse an x and a multiplier. 3/4 times 2/3. 3/4 times 5/9. This is example number 2. And what they're going to show you here is sometimes before you even begin to multiply, you can cancel a common factor. What they're saying is you can divide a numerator and a denominator by a common factor before you multiply. And if you use that shortcut, you simplify first, and then you're going to multiply. And we like this because if we can cancel a common factor, or if we can divide a numerator and a denominator by a common factor first, our arithmetic is easier. So can you divide the numerator and denominator? Is there anything here that you can divide by the same number? Sure. 3 divided by 3 is 1. 9 divided by 3 is 3. So we're reducing, we're doing our division ahead of time. Now we can multiply our numerators together, multiply our denominators together, and we have done our simplification, or our reducing to lowest terms, before we did our multiplication. It just makes our work a little bit easier. Canceled our common factors, or divided both the numerator and the denominator by 3 before we started. And that was the problem that I did just a few moments ago, where I said 28 divided by 2 over 50 divided by 2. Here I've divided the numerator by 3 and the denominator by 3. It just looks different. This is what they call canceling common factors. So let me go ahead and do one final problem for you. This one says, multiply 2 1/6 times 9. 2 1/6 times 9. How in the world are we going to do this? Well, you're going to write whole numbers and mixed numbers as fractions before you do the multiplication. Write whole numbers and mixed numbers as fractions before multiplying. How do you write 2 1/6 as a fraction? Remember, 6 times 9 is 12, plus 1. Take the denominator times the whole number and add the numerator. So we end up with 6 times 2 is 12, plus 1 is 13. We have 13/6 times 9/1. It's easy to make a whole number as a fraction. Now what we're going to do is look for a common denominator. We want to look for something that we can divide the numerator by and the denominator. We've got a 6 and a 9. Both of these are divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Do we see any other common factors that we can divide by? No, we don't. 13 times 3. 3 times 1 gives us 39 thirds. I am perfectly content with this. This is an improper fraction not reduced to lowest terms. Why? Because I said 6 divided by 3 is 2. Oh my goodness. 2, 2. And this video is primarily being done for my kids right here in my hometown. I'm not going to go back and redo this one. We have a common factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. I knew when I multiplied these together that I'd made a problem because 39 and 3 are both divisible by 3. And I knew that I had already canceled any common factors. So now we're back to 13 times 3 is 39. 2 times 1 is 2. And this answer right here, I am happy with, because this is, though it's an improper fraction with the numerator greater than the denominator, it's reduced to lowest terms. If you wanted to convert it to a mixed number, you could. There's no real benefit in doing that, but I'll accept it. for now. Prefer that you keep it in improper fraction form. And if the teacher's saying, hey, do less work, why don't you go ahead and keep it at that? That's all there is to our first section on multiplying and dividing rational numbers. If you have two rational numbers that you're going to multiply together, two things that look like fractions, this right here is not a rational number, is it? It's not a mixed number. It is a mixed number. This is a whole number. You put both of them, convert them to rational numbers. Convert them to something that looks like a fraction. Cancel common factors ideally before you multiply because it makes your arithmetic easier. Once you have canceled your common factors, you multiply the numerators, you multiply the denominators, you verify, like we did, that our answer was correct, that it was correct and in lowest terms, and you're finished. It may be converted to a mixed number, but I do not prefer that. That's all there is to it. Work on those, and I'll see you next time.